All right, good morning, beautiful people. Thank you for joining us for the sixth annual Regenerative Planet Summit. Due to the technical issues we had with our live performance this morning, we will be doing a redraft of the presentation by Daryl Oster on recording evacuated tube transportation. So we are live and recording. Daryl, the floor is yours.
Okay, very good. The Alaska the Trans-Alaska Pipeline, um, built for moving oil and gas, is nearing the end of its useful life. And what this is about is TAPS 2.0. This is a little bit of an outline of what I'm going to be talking about today. The ET3 overview, the TAPS 2.0 project, Alaska stakeholder potentials, and the global vision for the future. ET3 is literally space travel on Earth. And what a lot of us often don't realize is that all of us have been traveling our whole lives this way, with most of us not realizing it. The Earth right now is traveling around the sun at 67,000 miles per hour, and the sun is traveling around the Milky Way galaxy at over 200,000 miles per hour. Part of the time, the Earth's velocity adds to the sun velocity, and part of the time it subtracts from it. And in fact, we're told that the entire Milky Way galaxy is orbiting the apparent center of the universe at around 400,000 miles an hour. The typical human here riding on spaceship Earth travels over 300 billion miles in an average lifetime. The technology that we are putting in place is bringing those space travel conditions down to Earth so we can all enjoy them in our surface travel here on Earth. The technology consists of magnetic levitation, and right here you can see highlighted with the pointer the superconductor elements attached to the capsule. And right down here you can see the full scale maglev components that have been built and clamped onto the top of the mock up, showing how it actually works. This was phase one of the project to build a demonstration, and the levitation force actually exceeded our expectations by about 20%. Here you can see detailed cross section of the maglev system. ET3 Global Alliance Inc. is now has about 400 licensees in 26 countries. Those licensees are experts in various fields, companies in various fields. Here you see in the photograph Professor Wong and his wife. He is the inventor of high temperature superconductor maglev. That is by far the best magnetic levitation system for ET3. ET3 can use any maglev system, but this offers many benefits for both the HTSM and also for ET3. Much lower drag than other forms of magnetic levitation. These are some of the reasons why ET3 costs so much less. On the upper screen, or the upper photorealistic rendering here, where my cursor is circling right now, you can see that the ET3 infrastructure is much smaller, much lighter weight, much easier to install, and uses a lot less material per meter than um, the maglev train infrastructure, or the high speed rail infrastructure, or the light rail infrastructure, or any of the Hyperloop proposals, or for that matter, a 4-lane freeway traveling along elevated structure. Down here in the lower, you see the cross section for a tunnel underground. This 4-meter tunnel compared to a much larger tunnel for high speed rail. This is 19 or 20 times more rock and earth to remove when tunneling underground. So this gives a little bit of an idea why ET3 can be built for less than a tenth of the cost of high-speed rail or less than a fourth of the cost of a 4-lane freeway. The project that we believe is the ideal starting place for ET3 is right here in Fairbanks. So you might say, why Fairbanks? Fairbanks is the center of Alaska, and Alaska, from our perspective, is the center of the world. The Bering Strait is the cheapest place to cross the ocean by far. And a great circle route that you see here is a straight line from the Gulf of Mexico down in Mexico. This travels over the Bering Strait and ends up down in Thailand somewhere. It's one of the longest straight lines that you can draw on Earth. It appears to be a curve here, but you put it on a globe, and we can go over some of that later in the presentation. The stakeholders here, we believe, also offer the best economic opportunities in the nation right now. There are other locations that are almost equal, and in fact, in some areas better, some areas not quite as good. The Texas Triangle, for instance, the Texas T-bone, we like to call it, is one of those. We want to stay with local manufacturing and supplies, and the phases of the project will be to do a proof of viability by making a local pilot here in Alaska. And that would be to tool the basic elements to cast the sections for the tube out of ultra high performance concrete. And then there is route specific design and planning that will need to take place with local stakeholders, the borough, transportation experts. We believe that the landowners. We'll get into that later in the presentation. But the key is to demonstrate all the key elements necessary to network ET3 like freeways are networked, and it will be automated, of course. And then with obtaining a right of way to extend that demonstration out and funding to build a practical system where the trillions of dollars worth of oil and gas that is known to exist in the North Slope can be moved at much lower cost to the ports where it can be put to use. And then the next stage in the phase would be to scale the production, the local production methods scaled up, and start producing miles per day. And then, of course, once the system is built, testing and commissioning, and eventually a global build out and expansion. Fairbanks is the center of Alaska, and Alaska is the center of the world. The Bering Strait is really the key to achieving this at the lowest cost possible. All of the right of way already exists here for doing a demonstration along the levee system, and very close by there are also gravel pits, and the alluvial deposits here can be used for the materials to make the ultra high performance concrete. Also making use of the silica fume, which is the smoke that has been taken out of the air for coal plants. And I understand that you here in Fairbanks use coal for most of your electrical energy production, and a waste byproduct of that usually ends up in land dumps and can be considered toxic because of its nano qualities that get into the lungs and so forth. That has to be disposed of at great cost. With ultra high performance concrete, that is a key ingredient to give the ultra high performance concrete its properties, its nano engineered properties. So ET3 uses of that can actually transform a local trash into a local treasure. There's a lot of challenges with ET3 as far as right of way that are different than TAPS 1.0. ET3 TAPS 2.0 has a different set of constraints. We rely on high velocity and high frequency to achieve capacity. So here in this graph, you see in the first column, you see the speed in miles per hour and meters per second, and then the time required to accelerate at 1G up to that speed or to decelerate from that speed. And then here you see the length in meters that it takes to get up to that design speed and the amount in miles. So if we're looking at 400 miles an hour on the chart here, line number 18 where the cursor is, 400 miles an hour takes 1 mile to accelerate up to that design speed. That's world record maglev speed right now. The minimum curvature is 2.1 miles for 1G of lateral acceleration. That takes about 2.5 kilowatt hours of electrical energy, or less than a penny and a half per occupant in a 6-seat vehicle. To put that into perspective, that's about half of the energy of a 40-ton truck traveling at 70 miles an hour. So it might take a cup or two of diesel fuel to accelerate that 40-ton truck up to 70 miles an hour on the freeway. With ET3, there's no friction at that point, and the vehicle coasts its entire trip. Then, when it arrives at its destination, about 90% of that 2.5 kilowatt hours of electrical energy, which is about 8 cents worth of electrical energy, can be recovered at the other end when the vehicle slows back down. This next column is capsules per second. 12 capsules per second at a design speed of 400 miles an hour equates to about 12 times the capacity of a 4-lane freeway. 12 vehicles per second in each direction. And then you see the passengers per hour capacity of that. If each vehicle has 6 passengers, that's 260,000 passengers per hour in each direction. And this is the cargo limits. If each pallet has 410 kilograms of cargo, that's 17,000 tons per hour. It would take about 313 airlocks at each end to exploit that capacity. And if each capsule had data, this is the amount of terabytes per second if the full payload were filled with micro SD cards the size of my fingernail. 2.5 million terabytes per second. That's way more than the entire global internet traffic. The maximum power is at the maximum acceleration, at the maximum speed, is about 107 megawatts. And this is the per airlock megawatt. This is the amount of electrical energy that is converted into kinetic energy at the maximum speed of this design speed at 400 miles an hour. So we would have, this would be capable of transporting up to 108 megawatts of electrical energy to the end location. Of course, at higher speeds at 4,000 miles an hour, you multiply all these by 10. And one pair of 5-foot diameter tubes going across the Bering Strait at 4,000 miles an hour could carry, each one with only one pallet of cargo, could carry 5 times more cargo than all of the container ships traveling between China and the United States. Alaska also has some special challenges and constraints with regard to topography. We thought we had high mountains in Colorado, and you guys have some real mountains here in Alaska. It's going to take tunneling techniques to get through some of those mountains where necessary, going around them to the greatest extent possible, and finding the best places to deal with those geological constraints, topography constraints, temperature constraints, precipitation constraints. Precipitation in the form of snowfall can lead to avalanche risk, and there are sections of ET3 going through mountain valleys, for instance, that will very likely require some protection from avalanches. And of course, ET3 honoring the comfort limits for the passengers, and not making the vertical changes, going up and down hills feel too much like a roller coaster, or going around corners too quickly. More like the limits in a automobile or aircraft, and what we're already used to on a daily basis when we use those modes. ET3 will generally be more comfortable because the alignment is better, and it is more predictable. You won't have potholes with the vertical accelerations that are uncomfortable when you hit those traveling at high speed. Um, power supply constraints. ET3 in most climates can handle its own power supply, but here in the winter, solar cells on the top of it are not going to function very well for months at a time. So the power supply, however, is less than 1/100th of the power supply required for high-speed rail, for instance. The economics, we already talked about a little bit. And one of the biggest constraints, one of the biggest challenges of any infrastructure project is the politics involved. And that's just something that, requires the stakeholders coming together and figuring out what works best for everybody. The key stakeholders that we see for TAPS 2.0 are primarily the users. We like to look at things first from a user perspective. There are two major classifications of users for ET3, and that is to move cargo and also for passengers. And we believe that that there's plenty of need here in Alaska, and the users need, of course, low cost, reliable, fast, and safe capacity to move what needs to be moved. The reliability of ET3 is much higher reliability than other modes, with the adverse weather conditions almost immune from that. And then the perspective of the stakeholders of landowners for supply of the right of way and where ET3 is going to be going through. About 58 to 65% of the state, depending on whose statistics you look at, is owned by the federal government, about 28 by the state, and about 13% from First Nations. And my understanding is that that has moved from the low 60% to the high 58, and for the federal government, that has transferred quite a bit more land to the First Nations, that have moved up from roughly 10% to 12 or 13% presently. I hope somebody can confirm those statistics. And so this is the relative importance of the landowners in being involved with the process. Of course, the federal government has given jurisdiction to the local state government for transportation projects. If they use federal funds, there are regulations that have to be met, and some federal guidance, but mostly it's local people that have jurisdiction over that. So the primary landowners where ET3 is going to be going across are vitally important to realize the vision of TAPS 2.0. Finally, the ones who are likely to profit the most are the key stakeholders of the builders, the manufacturing facilities, labor to put everything into place, the pipe fitters, the suppliers, the engineers, the financiers, bankers, real estate acquisitions. Um, all of these key stakeholders need a positive return on investment and a positive return on assets. And as we'll see in a few minutes here, um, those are all maximized with TAPS 2.0. From a user perspective, we believe that the lowest hanging fruit here is cargo needs, specifically for oil and gas industries. ET3 can move, as you see here in the capsule, it can move barrels of oil, up to 3 barrels of oil at a time per capsule. It can move minerals that are mined. You have a lot of mining here in Alaska, a lot of timber production, and getting supplies to the workers for those extraction industries, um, fresh food and pallet at a time delivery very quickly, but also passengers for workers who are working in those adverse conditions in all weather and all seasons. The commuters that commute on a daily basis. We believe that the oil and gas industry will also enjoy much lower costs, much higher employee retention, and a lot of savings in per diem if their workers can go home every evening. Happier workers are likely to stay at the job longer and cost the company less in the long run, and the workers will likely make more money also. So many wins for the industries that exist up here because of the high cost of transportation in the harsh environment and how much that will be reduced by ET3. So looking at the landowner from the landowner perspective, if we look at who owns Alaska, there's a lot of existing right of ways that perhaps some of those can be utilized for ET3. This is where the Trans-Alaska pipeline crosses a floodplain, and I asked the guy from the TAPS 1.0, the Alyeska pipeline management company. I said, the pipeline, it shows it's going through here somewhere. Where is it? And he said, you're standing on it when I was taking this picture. The right-of-way planning issues are vitally important. I was a little bit dismayed when we attended the town hall meeting in Fairbanks that the language was being proposed to discourage new industrial uses. And I was encouraged that at least 3, or maybe it was 4 of the council members were also dismayed by that language, and I think that's going to be taken out. As an industrialist, we might think of industry as being dirty, but industry can also be clean with 3D printing and stuff that doesn't have any significant waste streams, the noise, the vibration, and pollution that's often associated with industry doesn't necessarily have to be the case. So I think we need to focus on encouraging clean industries that improve the living conditions and the living qualities. And let's do discourage the things that pollute and cause problems for everybody. But that doesn't necessarily follow that industrial use is associated, has to be associated with the dirt and filth that often goes along with it, and the eyesores that people have to look at on a daily basis, and the belching smokestacks and those types of things that we think of when we think industry. There are a lot of clean industries as well that need to be encouraged and not discouraged. So I'm very impressed with the town council at recognizing that. And the transportation component, I did not see in there that it looked forward to future technologies and keeping an eye on and keeping up with in a 2040 plan. That's 16 years from now. So a lot can happen. A lot has happened in the last decade, and a lot more will happen in the future decade. We need to consider transportation advancements. The Wright brothers, they got started with bicycles before they came out with aircraft, and bicycles are over 100 years old. They still work pretty good most places, but here in Alaska, I was encouraged to see that they are having a more realistic approach and saying instead of year-round bicycle network, that it would be a seasonal network. So I think much more can be done in looking forward to a 2040 plan and vision with respect to transportation. Some of the landowner benefits are very clear for ET3. The preservation of the environment and ultra clean is what really comes to mind. ET3 is virtually silent. It uses 1/50th of the amount of energy, 50 times more transportation per kilowatt hour than the most efficient electric car or electric train. That means it's 1/50th as much pollution for the generation of that electricity, and virtually silent. Sound can't be transmitted in or out of a vacuum. So as you travel, if there's noise through the area that you're traveling, you won't be bothered in your vehicle. It will be virtually silent, much better than the quietest limousines. And there will only be a very slight electrical hum where the linear motors accelerate the capsules up to speed. But most of the right-of-way will have virtually silent operation, and it will be available in virtually any weather situation. Also have real-time traceability for the landowners. So whoever goes across their property, if there's a problem at any time, it's traceable. The land value is likely to increase for the landowners because of access to transportation. We all know that if you're right on a freeway, it might reduce your property values, but if you're close to a freeway, it increases property values. With ET3, we have less of the negative impacts and more of the positive impacts. It's the lowest cost for a given capacity. It's much higher privacy in the vehicles, and a controlled environment, much warmer or cooler, depending on if cargo needs to be kept cold. The vacuum state inside the tubes is an ideal insulator. Just like a thermos bottle will keep your drink much hotter or much cooler for a much longer period of time than a small piece of foam insulation. And that is less impact to the environment than the TAPS 1.0 that even though it's insulated with 4 inches of foam, vacuum insulation is much more effective at insulating the environmental temperatures from the temperatures inside the capsule. This can all be built with existing equipment, materials, technologies, and capacities. It's also benefits landowners that their land won't have to be torn up to near the degree. If ET3 crosses their property, they'll be getting income from it instead of just a lot of negatives and no positives. So is ET3 going to be built now with local labor, local materials, local production capacities? Are we going to wait until the robots build everything for us? That's for local people here in Alaska to decide. And ET3 is an open consortium of over 400 licensees that are bringing ET3 to reality. And we are committed to going where that is the easiest, where we're wanted and the communities that want ET3 and the long-term benefits that it offers. We're very excited to be here and very thankful that for Robert Shields and ARC to make this possible with Bob Hubbard of the UA Local 375 Pipe Fitters Union and the training facility here. Thank you very much for making this possible and accommodating our trip. The building of ET3 is going to require a diverse skill set. Trucking, if you think TAPS 1.0 was a big project, ET3 TAPS 2.0 will require twice as many miles of pipeline if it were the similar 800 miles. But we're also proposing a collector route that would go east to west or west to east across the entire North Slope to collect more, a lot more of those resources that are up there and do so in a much more environmentally sustainable way than the existing methods. And also be able to move other cargo and passengers at the same time. So that will require welders, pipe fitters, electricians, control experts, security experts, heavy equipment operators, planners, investors, financiers, real estate and land persons, maintenance personnel, the engineering sciences, geotechnical sciences, graphic information systems, logistics, cartography, material suppliers, et cetera, and myriads of secondary skills that will be attracted to this area to deal with a much more of a boom town economy that was prevalent back when TAPS 1.0 was being built. ET3 is a global vision. Once the economics of ET3 start to become apparent to the rest of the world, if everything's built to the same standard in every country, eventually ET3 can be networked together across the Bering Strait. It might be so apparent to people that want to build walls like the Chinese did at one point, building the Great Wall of China. We believe it's much more powerful to build bridges across cultures and to make friends across cultures. And we believe that ET3 will offer the opportunity to make a global crossing at the Bering Strait. And instead of billions of dollars flowing through the Fairbanks area, it will literally be trillions of dollars flowing through this area. The transition that's already occurring of mobility and transportation from fossil fuel use to electrification enables durable, clean use of oil and gas to build high-tech building materials that offer ultra insulation capabilities. Maybe R60 or R100 walls and roof and floors will become much more common. Energy use dramatically reduced to keep warm or to keep cool in extreme climates like Alaska. And those oil and gas resources can be put to use for much longer purposes, making durable building materials, durable composites for aerospace structures, or making capsules for ET3. Eventually, 90% of global travel can take place within evacuated tube transport technologies. Presently, that's about $15 trillion per year. And that can enable a 10 to 20 hour work week instead of a 40-hour work week for basic survival. Cities will be free of noise and smog. You won't have to worry about your kids playing out in the street. You'll encourage them to go play out in the street instead of being fearful that they might be run over by a car. Um, Free travel can be paid for by advertisers. As people travel long distances for a couple hours, there will be a captive environment. And just like internet advertising pays for your internet use, the incremental cost of ET3 is so low that it's very likely, and the targeting is very good because of the traceability, that you'll be exposed to the types of advertising that you're likely to like and be more apt to watch. Or if you watch a half-hour presentation, it might pay for your trip to see the Taj Mahal, for instance, and only take a couple hours. So lots of possibilities with ET3 in the future as it displaces existing modes. In the future, it could be the lowest cost access to low Earth orbit, global movement of water and energy, transformation of trash to treasure. We've only scratched the surface of that with the power plant issue here, but there are many other instances where what is piling up as waste in one location. In fact, right here, we've noticed here in Alaska that there are, I think I heard them called Alaskan flamingos, where we've noticed, a lot of places have maybe 10 or more disabled vehicles that it's too expensive to haul them off since they're disabled. So they just sit around. That is a resource, maybe worth up to $100 or $200 per vehicle. If those were ground up and put in ET3 capsules, they could be moved out of here at less than a tenth of the cost presently, and offer a big resource for the places that they've been dumped off. So transformation of trash to treasure is something that we believe that could work here locally. Alaska is at the center of the world and vastly improved land value. We want to thank Fairbanks visionaries like Robert Shields and ARC and Bob Hubbard, the UA Local 375. Thank you very much for making this trip possible, and we really appreciate being here. Thank you.
Okay, thank you, Daryl, for all that great information. Could you tell us a little bit more about the licenses and how all of that stuff works out? What people get when they buy a license, and what are the processes of how that might
how all of that stuff works out? What
Yeah,
people
sure.
get when they buy a license?
The license is. Hold on a second. Let me. Close this and okay. Yeah, the license is first and foremost to use the system. Everybody that uses ET3 will need to be a licensee. And it's a lot like a driver's license. There are certain security needs of ET3, and just like your internet provider wants to know who you are before you're allowed to use the internet connection. Same type of thing with ET3, and that has costs associated with it. The license is $100 per individual, or a corporate license is $500 up to 5 seats, and then scalable at $100 per seat after that. And then there is a value added royalty, presently 6%, but proposed to go up to 10%. So if you sell anything that gets used in an ET3 system, it will, if you add 10% to that, you pass on the cost of your license onto onto the end users. So the license is also needed to work on an ET3 system. If you want to work on building it for a contractor, you'll need to be a licensee, or the contractor will need to be a licensee at the corporate level, and have a slot for you to fill as a licensed laborer or welder or whatever job that you're doing will need to be licensed. And it's much like software is licensed. So another aspect of it is to improve the technology. A lot of licensees in the past have we focused on licensees that have key intellectual properties. For instance, the inventor of the high temperature superconductor maglev, Professor Wong in China, is a licensee. And as systems are utilized, the cost of the magnetic levitation might be, say, 10 or 20% of the cost of the system. Of the royalty income that comes in from users, almost half of that royalty income is shared among the technology providers according to the relative value of their intellectual property in relationship to the cost of the system. Does that answer your question, Robert?
Yeah, that's a lot of information to process. And fortunately, we're grateful that you've participated in the summit before. So we have other recordings, and then I think we did a special for you. So there's a lot of information out there for folks to understand how the system works and how it's going to work for us. Our next steps are working to coordinate with a couple of different mayors and communities.
Fortunately, we're
exploring
in
the
the
line here in
summer
Fairbanks,
so we have other recordings, and then I think we did a special for you. So there's a lot of information out there for folks to understand how the system works and how it's going to work for us.
Cargo.
Our step, we work with the different mayors and communities. We're exploring a line here in Fairbanks that could eventually run from the Fairbanks International Airport down through North Pole to Eielson. And then that would be our city of Houston, and looking at possibly having a line that would run from Tufts for people movers. And then it's been looked good opportunities for the mines. And so we've reached out to see if they might be interested in a line from where they're at to Constantine, which is where our port's at. So all of these could eventually connect into an international transport line. And this technology, I think, could be very effective at driving a peace economy. Right now, we're driven by a war economy because that makes more sense, but we're also selling coal as a fuel source because that seems to make more sense.
And I appreciate you bringing this technology to our attention, because
using our waste to build a future that's bright for all of us is, I think, something that we can all understand and appreciate. So
your contact information
is on your website. And is there anything you'd like to share last as we head out the door?
Well, thank you very much for being here today, and we are very excited at the future prospects here in Alaska. Thank you.
All right. Well, thank you everybody for joining us today, and for your patience with us as we work through audio and technical issues. But look forward to seeing you at our Matnuska Thunder Festival.
Audio and technical issues, but look forward to seeing you at our Matsuda, and then we'll see you for the future.
So
thanks, Daryl, for coming, and thanks everybody for watching.
Have a beautiful day.
Have a beautiful
My
day.
pleasure. Thank you.